Hey, hello and welcome to today's GFG problem. The day uploading well. So let's say today's problem level order traversal. So what the problem saying is we'll be given a root of a binary tree with n nodes. Okay. Our task is to find its level order traversal. Level order traversal of a tree is breadth first, traversal for the tree. So here is a sample binary tree given. Okay. So we want to find out the level order traversal. So root is here, right? Root is here. Okay. So what will be the level? So what is the level order traversal first of all? So levels are, for example, how many levels are there in this particular tree? So this is the first level, level one. This is second level, level two, and this is third level, level three. Okay. So we want to print or we want to return the elements in according to the levels. For example, according to the first level, it is 10. Then comes a next level, which is 20 and this particular level, right? So the elements will be 20 and 30. The last level, the next level is this particular level, right? So it is going to be 40, 50, 60, and 70. Okay. So we want to return the elements in this particular order. Okay, so this is the ask. I hope you have got the ask. Now let's come to the approach. So how are we going to solve this problem? So we are going to use the breadth first traversal of the binary tree. Okay, now in order to do the breadth first traversal, we generally use a queue. Okay, the queuing mechanism. So what we're going to do, let's have a queue here. So let's say we have this queue, right? So queue, you know what is a property. First in, first out is a property of queue. Okay, so what we're going to do? So here, first of all, we are going to insert 10 in the queue, which is a root. Okay, and we are going to run a while loop until queue is not empty. We are going to run the while loop. Okay, so what we're going to do now? So first of all, okay, now we go inside the while loop and we're going to pop this element out. Okay, no, before popping the element out, we will have the size of this particular queue. What is the size? So currently the size is one. Okay, currently the size is one. So we'll take the size and we will iterate. We will iterate. We'll have a for loop. Okay, we'll have a for loop. Okay, which will iterate from size from I equal to 0 to size. Just be with me, you'll understand. Okay, I think let's code, you'll understand better. So first I'll show the Java code followed by C++. As I told, we are going to take a queue. So let's take a queue. Queue will be of type node. Okay, queue equal to new linked list. Okay, so this is the way to implement a queue in Java. Okay, now what we're going to do, we are going to ingest or insert the root, right? We inserted the root. Now we are going to run a while loop, as I said, right? While queue is not empty. Okay. Okay. And what we're going to do, we are going to take the current size of the queue, whatever the size, for example. And what does the size mean? So how many, so size means the queue size means the number of elements in the queue. Okay. So this will give the current size of the queue. Okay. Now what we're going to do, we are going to run a while loop, sorry, a for loop, int I equal to 0. Just be with me, you'll understand. Plus plus I. Okay. Now what we are going to do, we are going to pop out the current element from the queue, queue.poll. Queue.poll means, so whatever the element was inserted first will be popped out. Okay, with queue.poll. Okay, now what we did, we took the size. Okay, we have started the for loop. Okay, we are having a for loop and now we have popped out the element into current. Okay, we have popped out the element into current. Now what we are going to do with this, we are also going to, will have a uh, an array list, okay, an array list of integer, and it will have all the elements in that particular level. Okay, all the elements in that particular level. This will hold all the elements in a particular level. So what are we going to do? Level elements. Let's say we're going to add the current dot data in this. So what we have done? So we have this list, right? We have, let's say the list is here. Okay, the list is here. Okay, the list is here and we have what we have done. We have put this 10, data 10 into the list. Okay, data 10 into the list. Okay, now and here, whatever is a popped out element, right, which is current, we'll check for the left and right node. If current dot left is not null, then we are going to add in the queue. Add current dot left to the, okay, and we are also going to check for the right right child. Q dot add the dot right. Okay, so So what we're doing, so whatever is the size, the whatever was the size, right? Whatever was the size, we are iterating the for loop, okay, till that particular size, and we are ingesting the element into from that particular level, So in this case, so here we have added 10. Okay. Now the size was 10. And we have also, what we are doing here is current dot left. Whatever is the current dot left and current dot right, we are adding the left and right child. So what we're doing, so we popped, so it was earlier 10. Now we have added this left and right child of 10, of 10, right? Which is 10, 20 and 30. Okay, 20 and 30. Okay. So our for loop will break here now, because the size of the cube when 10 was there, it was 1. Okay. So what we've done till now, we have added this level elements, the 10 into the level elements, okay, and we have also added the left and right child of 10, right, into the queue. But it does not mean that this for loop is going to run 3 times, because we have added 10 and 20 and 30 in that. Whatever was the size when 10 element was there, okay, so that means 1, so it is going to run once only. Okay, so once this for loop is done, we have all the elements in from that particular level. Okay, so we'll have one more final result, right, result list, which will be arrow of array list. Okay, result, let's say new array list. Okay, now what we're going to do, post this for loop, we are going to add whatever the elements from this particular list. Okay, that means we have added the elements of a particular level. Okay, we are done here, like at least the first level is done. Now the next level will be started, and we first here will have a check whether queue is empty or not. The queue is not empty, so now we'll take the size of the queue, which will be what? Now the size of the queue will be, 2, right? Size of the queue will be 2. Now we go inside this, we have again the list, okay, for the elements of that particular level. This will run 2 times, right? Because size is 2, because of 20 and 30 element. Now we are popping out 20, right? We are popping out 20 now. Okay, so we popped out 20, we have 20 in the current. Okay, and we are also going to ingest 20 in this particular level elements list. Okay, so now this will be, sorry, this won't be 10 now. This won't be 10. This will start from what? Let me, this won't be 10 level elements list. It will start from 20. Okay, so this is the first element of that particular level, 20. Okay, now what we're going to do, we're also going to check whether 20 has left and right child. Yes, they have. So we're going to add in the queue 40 and 50, right? 40 and 50. So that's what we've done here. So what we've done, 20 we are adding in the this level elements array list, and then we are also pushing whatever is the left child and right child of 20. Okay, we are pushing in the queue. Okay, we did that. We are pushing in the queue. So 1450 pushed. Again, this will run this for loop, as I said, it will run twice, right? So now we'll pop out current, which will be what? Which will be 30. Okay, 30. Here it is 30. Okay. And we are also, what we're going to do, we'll add this 30 into this particular level elements array list. Okay, which is 20 and 30. This is not there, 20 and 30. Okay. Also, we'll push the left and right child of 20 and of 30, sorry, of 30 into the queue, 60 and 70. Okay, so this is a queue state. Okay, now, so we have done, no, so now our that particular level, right? It is ready. All the elements have been pushed, which is 20 and 30. And finally, we are going to add in this resultant list. Okay, this resultant list. Next, what we're going to do, we are going to check if queue is empty, node is not empty. We'll pop this out. Current will hold 40. We'll take the size, which is 1. No, sorry, not size is not 1. Sorry, the size will be what? Sorry, before popping out, we'll take the size, which is 4. 40, 50, 60, and 70, which is 4. Size will be 4, right? Size will be 4, and we'll pop this element out now, which will be 40. Okay, and we are going to add into our level elements list, right? Which will be 40 here. Okay, 40. And we are going to check for left and right child. So does 40 has left and right child? No, they don't. No, it does not have. So we are not going to add. Okay, we'll pop out the next element. Okay, this for loop will run till 4, right? Okay, 4 times. Okay, so 50 we popped out. Current holds 50. We are also going to add 50 in this level elements list. and we're going to check for left and right child of, no, it does not have. So we'll just ignore, we'll go ahead. We'll pop out 60 now. Current value of 60. We'll add 60 here into this level list. Okay, into this level list. And we're going to check for left and right child. No, it does not have. Then we're going to pop this out 70. Current holds 70 now. We're going to add 70 here. Okay. And we'll check for left and right child. No, it does not have. Okay. So our level is this list particular is ready. We're going to add in the resultant list, this 40, 50, 60, 70. This is a third level. Okay. Now we'll check in a while loop whether Q is empty. Yes, it is empty because there are no elements here, and we'll break out. And once breaking out, we will simply return a result. So this is it. This is the intuition behind solving the problem. And also you have your code ready. Okay, I've tried to make it very easy for you. Just one request to please subscribe to the channel, like the video. Okay. So we'll see the C++ code as well. Test cases are being processed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code. Not much difference here. So here we have a queue. We are pushing the root. Then we are running a while loop until queue is not empty. We are taking the size of the queue. And then we are taking this temporary list or vector, we can say. And we are running whatever the size of the queue, whatever was the size of the queue, right? So we are running the for loop. And now we are popping that element, whatever was the first element. Okay. And we are pushing into the temp, and then we are whatever we left and right child we have, we're going to add in the queue. Okay. And finally, yes, one. So after each level, we are going to add in the our resultant list. Okay, which is the final answer. And at the end, we are going to return this result list or vector. So this is it. Thanks for watching. I hope you've got the solution. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.